Subscribe to Mr. Ang's Math Class and remember to check all of your work.
Hey math lovers, let's go over quiz number 7, 4-1 to 4-3 on probability, March 15, 2022. Use spin the spinner shown below once. The spinner has 4 equal sectors, pink, purple, blue, and green. What is the probability of landing blue? Well, if you count 1, 2, 3, 4, so all versus what you want, we want just blue over all. So blue is just one of the sections over there's 4 sections. So 1/4 is your answer, and I think I told you guys to put as a decimal 0.25. You would type into your calculator 4, you would do 1 divided by 4, which would go, 4 goes into 1, and it'll give you the 0.25. Question number 2, you toss a coin, a fair coin, so that just says that it has equal chance of going either heads or tails, 2 times. Both times it landed on tails. The probability of landing on tails on the next toss is, the question is, are the 2 events affected by one another? And the answer is no, they are not. And this has to do with the idea that there are no hot streaks, right? You're like, oh no, it just landed on tails 2 times, so it's going to be harder to find tails, but in the long run, it's still the same, so 0.5 is your answer. Question number 3, the probability of an event happening is 0.45. So let's call this probability of event A is 0.45. What's the probability that it does not happen? So not happening, remember these have to add up to be 1. So this would have to be 0.55. So that would be this choice right here. Remember, it's kind of like if it's 45% rain, then the chances of no rain is just the complement. So they have to add up to 1. Question number 4, true or false, the probability of an event can be greater than 1. Remember, 0 is not possible, 1 is possible, and it's just a range between these 2 numbers. So can it go over 1, like over here? The answer is no, so that would be false. Omar ordered his sister a birthday card from a company that randomly selects a card from their inventory. The company has 21 total cards in inventory, so total is 21, and 14 of those are birthday cards. So total cards, B-Day cards, there are 14 of these. What is the probability of the card chosen is not a birthday card? So I want this to add up to be 21 over 21. So this is B-Days and no birthday card. Well, this would have to be 7 over 21, right? Because I'm just adding the numerators to get 21. So that would be 7 out of 21. And that would be the first one for number 5. Number 6, the following bar graph summarizes the weather conditions in Middleborough for the selected days in December. Based on this data, what is the probability that a random day was sunny? Well, I want a total, or probability that it's sunny is going to be the total over the sunny days. So sunny days is 3. And then the total is 3, 5, 2, and 2. So that would give me 8, 12. So this would reduce to 1/4, which is 0.25, or 25% B. Question number 7, the probability of rolling a single die and landing on a number less than 6. Okay, so if I list out all the numbers, 1, 2, 3, 4, 5, 6. And I want numbers that are less than 6. Not less than or equal to, but smaller than 6. So this number, this number, this number, this number, this number, not this number. So basically I want these. So the probability of less, so draw it out, draw yourself a picture, less than 6, remember, is what we want. In that case, that is the 5 numbers, right? 1, 2, 3, 4, and 5 are less than 6 over the total. So that's the all. So my answer is going to be 5, 6. Question number 8. Select the option below that is incorrect or wrong about the simulations. A, simulation can be used to perform multiple trials from one particular context. I'm going to write A as true and X as wrong or incorrect. So yes, you can keep doing a simulation, right? Like, will it snow? There's a 30% chance that it snows today in the mountains. And you keep performing the simulation and you get an idea over multiple times. B, a simulation can be used to evaluate the exact percentage. I'm going to underline the word exact. Right now is the Ukrainian invasion, and so if they do a simulation, they might say, like, how many days will Ukraine survive all the bombings and the invasions? They can't get an exact, they can get an estimate. So I'm wary of this one. I'm going to put this one as my incorrect. But let's go through the other choices. C, a simulation can be done by hand or with technology. That is correct. And D, it is better to do a simulation with a large amount of trials than a simulation with a small amount of trials. Yes, because that's the point. Technology or by hand is to figure out, like, if that works or not. So question number 8, our answer is B. This is the incorrect statement about simulations. Question number 9. For two mutually exclusive events, so remember, mutually agrees, this is event A and this is event B, there is no overlap. There is no relationship between A and B. They mutually agree to exclude, to exit one another. And what that means is you don't have to subtract any overlap. You don't have to subtract any double counting. That's the idea here. Probability of event A is 5 out of 10. And probability of event B happening is 1 out of 10. What is the probability that either, so that would be or, probability of event A or B happening, which is equal to the probability of A plus probability of B. So probability of A is 5 out of 10 plus 1 out of 10. You add the numerators, and you're going to get 6 out of 10, which I don't see any fractions over there, so that would be 0.60. B is our correct answer. Now, if there was an overlap, if they didn't tell us for two mutually exclusive events, they might say the probability they're overlapped, then we would subtract that, or the double counting. Question number 10, a local dealership has 100 vehicles on its lot. So I'm going to write N equals 100. The chart below shows the number of cars, vans, and trucks, both new and used. What is the percent of new cars that are new? Okay. What percent of new vehicles? So how many new total? Okay, so that would be this row. And if I add all those up, I would get 11, that would get 20. And I just want the probability of a new car. The probability of the car is new. And that would just be this box right here. So 4 out of 20, 4 times 5, and this would give us 1/5, or about 20%, which is choice C. And number 11, Isaac surveyed his classmates to find out the types of pets they had. The pet results are listed below. Okay. There are a total of a total of 25 dogs. Okay, so when I think of dogs, that means like this circle would have to add up to be 25. 9, 12, 25. This one matches. Dogs. This one has too many dogs. This one has 9 plus 4 is 13. 13 plus 7 is 10. 10 plus 25, this has 35 dogs. That's bad. So no, 25 dogs. Same thing over here. 9, 4, 13, 25 dogs. This one matches right now. And this one has too many. 5 plus 4 plus 3 would give me 9, 12, 37 dogs. Okay, now what else we got? 28 cats. So 19, 23, 23, 28 cats. Is that what we wanted? Yes. Let's go just to the check mark ones now. 15 plus 4 is 19, 19, 28 cats. All right. 30 fish. 7, 16, 30 fish. Okay. Down here. 17, 23, 30 fish. Okay, let's find something else now. There were 9 students who had only dogs and cats. So look at the overlap for cats and dogs. That would be this one, 9. C plus D. That matches. Okay, this one has 9 plus 4. Because that one is saying there are 4 students that have cats, dogs, and fish. Nope. So this would be 9. 9 cats plus dogs. So let's go back up here. This one has 5. Let me explain that one again. So this one has this particular area in black that I'm putting in. This one is 4 that are, notice the overlap is in all 3 circles. So that's cats, dogs, and fish. So not this one. So it would be choice C is our answer. And that was it. Hopefully those corrections were helpful for you for this quiz. We'll see you guys later. Bye.
It's Kermit the Frog. I just want to say I love math. Ha 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 ha. So, Mr. Ring.